Chemists use isotopic labeling by replacing specific atoms in a molecule with heavier or rare isotopes, so those atoms can be tracked during reactions or identified in spectra. Think of a molecule as a toy train where one car is painted a different color, so you can follow it through a big model city. Isotopic labeling is like painting an atom with a heavier version so instruments can see where it goes. Scientists swap in isotopes like carbon with the mass number 13 or nitrogen with the mass number 15 at chosen positions in the molecule, then run the reaction or record spectra with tools such as nuclear magnetic resonance or mass spectrometry to observe changes. The labeled atom shows distinct signals or mass shifts that reveal which bonds form or break and how atoms move between molecules. This method helps answer questions about mechanism, product formation, and which parts of a starting material end up in a product. Students often think labeling changes how the chemistry works, but usually the chemistry is the same because isotopes differ mainly in mass, not chemical behavior. If a reaction is very sensitive to mass changes, use lighter labels or test controls to check for kinetic isotope effects. Another common mistake is placing labels randomly and expecting clear answers. Plan labels at positions most likely involved in the step you want to study. Some assume any instrument will detect any label, so confirm instrument sensitivity first, and choose an isotope and detection method that give a clear signal. For more videos and resources on isotopic labeling and related experiments, check out www.gumballdegree.com.